Welcome to this explainer. We're jumping right in today because we're looking at how a dormant, dusty planet is actually acting as a cosmic crime scene, one that can reveal the origins of our very own Earth. We're talking about Mars, of course, and we're going to discover how a tiny, completely stationary robot managed to unlock a 4.5 billion-year-old mystery buried deep beneath the Martian surface.
Now, there's a really stark contrast between our home and the red planet. See, Earth is incredibly active. It's got this churning interior that constantly recycles its crust, literally erasing its own geological history through moving tectonic plates. But Mars is cold. It's a dormant interior that froze really quickly, perfectly preserving its ancient structure. And here's the wild part. Even though these two worlds formed from the exact same primordial cloud of dust and gas, their divergent paths make Mars the perfect, untouched time capsule.
Section 1. A planetary time capsule. So, to truly understand our own planet's hidden ancient history, we actually have to look at the preserved fossil record trapped inside Mars. About 4.5 billion years ago, both of these planets were born. But because Mars has only about 1/10 the mass of Earth, it cooled down extremely fast. You can think of it like a small cup of tea cooling way faster than a massive full teapot. This rapid cooling completely halted its internal tectonic activity within its first billion years, freezing its ancient geological structure perfectly in place.
Which brings us to the crucial point, right? The central mystery of all this. If Mars is a time capsule, how exactly do we explore the inside of a rocky planet when we can't even see beneath the surface?
Section 2. How to X-ray planets. Let's think about this. If we wanted to drill all the way down to Earth's core just to see inside, we'd have to survive an absolutely impossible journey. First, you've got to penetrate 5 to 60 kilometers of crust. Then, you'd have to somehow withstand 1,000 degrees Celsius temperatures across 2,900 kilometers of solid mantle. Next up, passing through 2,200 kilometers of liquid outer core. And finally, you'd reach the solid inner core, sitting at a staggering 6,000 degrees. Obviously, our tools would literally vaporize long before getting anywhere near the center.
To put that sheer impossibility into perspective for a second, 12 kilometers. That's it. That is the absolute deepest humanity has ever managed to drill into our own planet. It was the Kola super deep borehole in Russia. It took 22 years to dig, and honestly, it is barely a scratch on the planet's surface. They actually had to stop because the hole hit 180 degrees Celsius, and things just became way too extreme.
So, since physical drilling is completely out of the question, scientists use seismometers to listen to planetary earthquakes instead. When a quake happens, it sends energy ripples out in every direction. The first to arrive are P waves, or primary waves. These basically act like a giant planetary X-ray, stretching and compressing the rock like a slinky. They move super fast, and crucially, they can travel through both liquid and solid layers. Then we have the S waves, or secondary waves. These are slower, and they shift materials side to side. But the absolute key detail here is that they can only travel through solid matter. They are completely blocked by liquids. So, by comparing how these P waves and S waves speed up, slow down, or just stop altogether, scientists can map out exactly where a planet's internal layers transition from solid rock to molten liquid. It's brilliant.
Section 3. The InSight lander's mission.
Let's jump to November 2018, when NASA's InSight lander touched down. Now, unlike a Mars rover, it didn't drive around. It just sat absolutely still on a flat plane. It deployed an instrument called SEIS, which is a seismometer so incredibly sensitive it could detect ground movement smaller than the diameter of a single hydrogen atom. Crazy, right? Now, a lot of people wondered if Mars would just be totally silent. But in April 2019, it heard its first Marsquake. And by the time the mission concluded in late 2022, it had recorded over 1,300 quakes, including a massive magnitude 5, proving that it was listening to a surprisingly noisy Martian interior.
For literally decades, scientists were basically just making wild, educated guesses about the interior. But InSight gave us the hard numbers. We finally learned that the Martian crust is 24 to 72 kilometers thick on average. The rocky mantle extends down 1,560 kilometers, and the dense core, which is made of iron, nickel, and sulfur, is 1,830 kilometers in radius. We finally had our complete planetary X-ray.
Section 4. A surprisingly lumpy discovery.
But as it turns out, the story doesn't end with just a simple map of layers. When a team of scientists analyzed this seismic data in the 2025 Science Journal paper, they uncovered a shocking twist hidden deep in the planet's mantle. The seismic waves weren't just traveling smoothly. No, they kept slowing down in these patchy, irregular zones. Konstantinos Charalambous, the lead author from Imperial College London, described it perfectly. He said, the pattern of these lumps was kind of like shattered glass, with a few large shards and many small ones. They realized that the interior of Mars isn't a smooth, predictable gradient at all. It's actually a chunky, lumpy mess.
So what exactly are these lumps? Well, these enormous chunks are actually ancient shrapnel. 4.5 billion years ago, during the really chaotic early days of our solar system, Mars was bombarded by giant asteroids and large protoplanets. These violent space collisions literally melted massive swaths of the planet into global oceans of magma. The impact fragments were injected deep into this magma, and as Mars rapidly cooled down, they solidified and got trapped underground. Some of these surviving massive chunks are up to 4 kilometers across.
And it gets better, because these ancient lumps might still be causing geologic trouble today. A 2024 study focused on the Tharsis Rise anomaly found a massive 1,750-kilometer-wide, incredibly light formation sitting about 1,100 kilometers below the surface. And it is actively pushing the colossal Olympus Mons volcano upward. This chunky interior might actually be driving massive dormant lava plumes right now, which is forcing scientists to entirely rethink how seemingly dead planets evolve.
Section 5. Blueprint for Habitable Worlds. So, what does this all mean? What do these giant, ancient lumps mean for us and the wider search for life in the universe? Well, it really comes down to 2 very different planetary fates. Tectonically active planets, like our Earth, constantly churn their mantles. This erases those ancient impact scars, sure, but that very churning helps regulate atmospheres and magnetic fields, which are the exact ingredients needed to sustain life. On the other hand, dormant, lumpy planets like Mars never mix their internal ingredients. They're barren today, but they perfectly preserve the chaotic, violent history of early solar system formation. We're now learning that Earth likely had these exact same violent, lumpy scars in its youth, but our planet's ability to keep its mantle churning might just be the exact mechanism required to create a habitable world.
So rather than a uniform, smooth chocolate orb, Mars's interior structure is packed with chunky remnants. Honestly, it's much more like a Snickers bar than a plain piece of chocolate. And by preserving this chunky state, Mars is serving as an absolutely invaluable, rocky blueprint for understanding exoplanets everywhere.
And that leaves us with a pretty profound thought to ponder as we wrap up this explainer. If a lumpy, dormant interior shaped a barren Mars, could hunting for these exact same planetary lumps, or maybe the lack of them, help us identify the next habitable Earth? As we look out into the cosmos, we really have to wonder, will this seismic blueprint be the ultimate key to finding our next home in the stars? Thank you so much for joining me today. I hope you found this as absolutely fascinating as I did.